In this video, I'll calculate the angular momentum of the Earth rotating about its axis. So I have here our list of knowns, and the thing we're looking for the angular momentum of the Earth. We weren't given all of this information. I had to look up what the mass of the Earth was and the radius of the Earth. Those are both in the inside covers of the Walker textbook. So knowing the mass and radius of the Earth, the angular velocity of the Earth, I know that the Earth goes around 1 time per day. So that's the information I need to use. And Earth is a solid sphere, so that's 2/5 mr squared for the moment of inertia. I know angular momentum is I omega, so that's 2/5 mr squared omega. So that's 2/5 times 5.97 times 10 to the 24th kilograms times 6.37 times 10 to the 6 meters squared times omega. Omega is 1 rotation per day. 1 rotation per day, that's not an SI unit. So I have to convert. Omega equals 1 rotation per day. I know there are 24 hours in a day. I know that there are 3,600 seconds in an hour. That's 60 times 60. So now, I did that wrong. This is a good example of why I always set it up and cancel units, because day on the bottom is not going to cancel day on the bottom. I have to flip that. 1 day per 24 hours. 1 hour per 3,600 seconds. All right, so days cancel, hours cancel. I'm going to get seconds on the bottom. That's good. Now I have to get my rotations into radians. So 1 rotation is 2 pi radians. .27 times 10 to the minus 1, 2, 3, 4, 5 radians per second. All right, I'm going to end up with kilogram meters squared per second. The radian goes away. That's the right unit. So now I just have to calculate. 7.04 times 10 to the 33rd kilogram meters squared per second.